Benzene ring structure and stability. Benzene is a ring of 6 carbon atoms, which has the molecular formula of C6H6, meaning it has 6 carbon atoms and 6 hydrogens. It has a planar cyclic structure, and in this structure, each carbon atom in the ring will have two sigma single bonds between the two adjacent carbons, and then we'll have another sigma bond or single bond with the hydrogen. So there are 3 bonds, and then the remaining unpaired electrons on each carbon is located in a p orbital. So these are the p orbitals which are sticking out above and below the plane of the ring. The p orbitals of each carbon will combine together to form a ring of delocalized electrons. So we can see here the ring of the delocalized electrons. So all carbon-carbon bonds will have the same lengths because they are not actually single bonds and they are not completely double bond. They are something in between. This is why their lengths will be something in between the lengths of the single bond and the double bond. So it's going to be shorter than the normal carbon-carbon single bond and longer than the normal carbon-carbon double bond. Benzene ring can be drawn in this way as alternating double and single bonds, and you can also draw it this way. But remember that these are not actually double bonds and single bonds. Okay, so the right way of drawing benzene is like this. When we draw this ring in the center of the whole structure, this cycle. So this cycle in the middle of the ring, the hexagonal ring, that means this represents the localized electrons, which means there is an electron cloud that actually rotating between all the 6 electrons without an actual sigma bond or single bond and double bond. The stability of benzene. Benzene is more stable than the theoretical cyclohexa 135 triene. So this is the theoretical compound, which is cyclohexa 135 triene. This is the cyclohexane ring with 3 double bond. They have alternating single and double bond, which is not actually a compound because the actual compound is benzene. So this is a theoretical hexatriene compound. So to compare the stability of benzene with this with cyclohexatriene, you can compare the enthalpy change of hydrogenation of benzene with the enthalpy of hydrogenation of the cyclohexatriene. So to calculate the enthalpy of hydrogenation of cyclohexatriene, we can start off with the hydrogenation of cyclohexene. This is the one that has only one double bond. So for the hydrogenation, the enthalpy of hydrogenation of this is minus 120 kilojoule per mole. So the predicted then enthalpy of hydrogenation of the theoretical 135, the cyclohexa 135 triene would be triple this amount, which is minus 360 kilojoule per mole. However, the actual enthalpy of hydrogenation of benzene itself, which is similar to this compound, but actually have the delocalized electron, and we draw it this way, the actual enthalpy of hydrogenation is far less than this. It's minus 208 kilojoule per mole, which proves that this is more stable than the cyclohexatriene. The reason for that is that energy is taken in when the bonds are broken, and then the energy is released when the new bonds are formed. That means because we have smaller value here for the benzene ring, that means that these double bonds would need much more energy to be taken in order for this bond to be broken. So this is why the enthalpy of hydrogenation is much less, and this is why it's much more stable, meaning it needs much more energy to break these bonds. Aromatic compounds, they come or derived from benzene. They have the benzene ring and they are called arene compounds. We can name aromatic compounds by simply looking at the substituents on the benzene ring. So if we have a chlorine atom, it's going to be called chlorobenzene. If you have nitro group, it's called nitrobenzene. If you have two methyl groups, you have to give them a number for their position. So this one, for example, is 1,3-dimethyl benzene. Then there are certain compounds which has special names like the benzene ring which has an OH group. This is called a phenyl group and this is called the phenolic OH and the compound overall is called phenol. When you have an amino group, this is called phenylamine or also we can call it aniline.